What if I told you that the moon is stealing from us? A cosmic crime is taking place 384,400 kilometers above your head. NASA data has confirmed something that physically shouldn't exist. The moon is covered in rust. Rust needs two ingredients: oxygen and water. The moon is supposed to be a bone-dry, airless vacuum. So, where is the oxygen coming from? The answer might be Earth. This discovery defies every single rule of planetary chemistry we've taught for decades. The moon is constantly bombarded by the solar wind, a stream of charged particles, mostly hydrogen, blasting out from the sun. Chemically, hydrogen is a reducer. That means it strips oxygen atoms away. It prevents rust. It keeps iron in its metallic, shiny state. So, finding rust on the moon is literally like finding a snowman inside a blast furnace. It shouldn't happen. Yet, a groundbreaking study in Science Advances confirms it. Massive patches of hematite, a heavy iron oxide, are spreading across the lunar poles. Scientists at the University of Hawaii and NASA's JPL were genuinely baffled. One researcher admitted that the moon is a terrible environment for hematite to form. If the moon is dead and space is a vacuum, who is painting the moon red? To understand why NASA is so alarmed by this, we need to establish the normal science. Rust is simply iron oxide. On Earth, making rust is easy because we have a damp, oxygen-rich atmosphere. But the moon is an airless world. Its atmosphere is a tenuous exosphere where atoms are so sparse they rarely even touch each other. Since the Apollo missions brought back soil samples, we've known a fundamental fact. Lunar iron is metallic. It is pristine. It hasn't reacted with oxygen because there is no oxygen to react with. But then, the data changed. In 2008, India launched the Chandrayaan-1 orbiter. On board was a NASA instrument called the Moon Mineralogy Mapper, or M3. M3 was designed to scan light spectra to identify minerals. For years, scientists pored over this data hunting for water ice trapped in shadows. But when they looked at the high latitudes, the polar regions, they found a spectral fingerprint that didn't match water, and it didn't match metallic iron. It matched hematite. Hematite requires free oxygen to form. The moon shouldn't have any. The mystery isn't just, what is it? But how did it get there? If the solar wind is constantly scrubbing the moon clean, something else must be overpowering the sun itself. The detective story begins with Shuai Li, a researcher at the University of Hawaii. It was 2018 when he analyzed the M3 data and noticed absorption lines in the spectrum that looked like rust. He was skeptical because he knew the physics, so he reached out to colleagues at NASA's Jet Propulsion Laboratory. They cross-referenced the data, and the result came back positive. But the team noticed something else, a clue that cracked the case wide open. They mapped the location of the rust. If the rust was caused by water inside the moon or by asteroids hitting the surface, it should be scattered randomly. It wasn't. The hematite was heavily concentrated on the near side of the moon. This is the face of the moon that is tidally locked, always pointing at Earth. The far side had barely any rust at all. This geometry is the smoking gun. If the rust is facing us, the cause must be coming from us. But Earth is nearly 400,000 kilometers away. Space is a vacuum. How does oxygen travel across the void to infect a rock that far away? It turns out Earth has a hidden weapon. Earth acts like a giant magnet. We generate a massive magnetic field that protects us from the sun. But the solar wind pushes on this field, stretching it out on the night side of Earth into a long, tapered shape called the magnetotail. Think of it like a windsock trailing behind a moving car. Once a month, during the full moon phase, The moon's orbit takes it directly through this magnetotail. When it enters this zone, the physics of the moon change completely for about 5 days. First, Earth's magnetic shield blocks the solar wind. That constant bombardment of hydrogen, the anti-rust agent, stops. The moon's defenses are down. Second, Earth is leaking. Sunlight hits Earth's upper atmosphere, energizing oxygen atoms. Some of them escape gravity and travel down the magnetic field lines. This is called the Earth wind. So, for 5 days a month, we blast the moon with a shower of high-energy oxygen ions. This oxygen travels 384,000 kilometers and slams into the lunar soil. Because the solar wind isn't there to scrub it away, this oxygen has time to react. It bonds with the iron in the regolith. We are literally rusting our own moon from a distance. Shui Li's study suggests this has been happening for billions of years. This explains the near-side concentration perfectly. It's the side facing the hose of oxygen. It's a perfect explanation, but science is never that simple. Just when you thought we understood the mechanism, the data gets messy. While the near side is covered in rust, M3 also found trace amounts of hematite on the far side of the moon. The far side never faces Earth. It never sees the Earth wind. It is constantly shielded from our atmosphere by the bulk of the moon itself. So why is it rusting? This implies a secondary culprit is at work. Scientists believe that tiny dust impacts, micrometeoroids, are hitting the poles. These impacts flash vaporize tiny water ice molecules trapped in the soil. This releases a microscopic puff of oxygen right at the surface level, allowing rust to form instantly. However, the near side is still significantly rustier than the far side. This proves that while local water helps, Earth is the main villain in this oxidation story. It's a cosmic tug-of-war. The sun tries to keep the moon gray. Earth tries to turn it red. And right now, we are winning. This matters for more than just geology. This rust is essentially a 4.5 billion-year-old hard drive. Since Earth has been leaking oxygen since the atmosphere formed, the layers of rust on the moon might record the history of our own planet. We could drill into the moon to find out what Earth's air was like during the time of the dinosaurs, or even before life began. But it also has a practical consequence. For the upcoming Artemis missions, this is a headache. We plan to refine lunar soil to build bases and extract oxygen. Rust is chemically different from metallic iron. It changes how we process materials. NASA engineers now have to account for weathered soil on a world with no weather. Unexpected chemistry is dangerous chemistry when you're millions of miles from home. The good news is, we don't have to guess for much longer. NASA's Artemis program and robotic scouts like the Viper rover are targeting these polar regions to sample these hematite regions directly. We are going to ground truth this theory. This proves that our solar system is a dynamic, interconnected living system, not just a collection of lonely rocks. The universe is full of rust, but it's the shiny parts that catch our eye.